And it's great to be here. Frank is also a tough act to follow. But these are exciting times because back in the times that Uday was referring to, working with Mike and with Frank on some of these market design issues for the what became the ISOs, now we're starting to think about, well, what are the implications of all this for the distribution system? For those of you who aren't quite familiar with power systems, transmission systems begin, our high voltage system basically down to the distribution substations. And so responsibility for operation of the systems and reliability is kind of divided into among different entities. The system operator or transmission system operator is responsible for everything down to that point, and then from there to the customer meter is considered to be the distribution system. And so that's what I'm going to be focusing on, distribution system operations, and how that interfaces with the larger bulk power system. So first, some history. Where's the, okay. Fortunately, Ben covered much of this, so I don't have to. Let's see. Yeah. There we go. Okay. So I don't have to really go over this. I think the group at MIT, including Fred Schweppe and Mike Karamanis, Richard Tabers, and Roger Bone, did quite a bit of work, designed to enable customers to engage in transactions and act in ways that would benefit the system as a whole, thereby having all of these benefits: economic efficiency, environmental benefits, et cetera. Judging at the title of Fred's original 1978 article, I think he envisioned that things would happen more quickly than they have. Power Systems 2000. But I guess all I'll say here is that this work culminated in the book Spot Pricing of Electricity in 1988. And I found an interesting quote in that book, which is, appliance manufacturers will start to produce appliances designed to be able to exploit time-varying prices. And this work underlies how electricity is now priced at the wholesale level, but it's only now beginning to be poised to have potentially huge impacts at the retail level. And so I'm going to show a chart here that I stole from Paul DeMartini. And the reason I like it is because I think it shows really well that we really are just in the beginning stages of this evolution of distributed operations. So I'm going to be talking a lot about distributed energy resources, demand-side assets, DERs, I'll call them at some point. I'm going to use the term in the broader sense to refer not to just generation, but also these other kinds of resources. Responsive loads, storage, and monitoring and control. And here I've listed a few examples of these, and you can see that some of them are in widespread use today, and others are really maybe down in the lower right-hand corner, are just still to some extent in the research stages. Now, apologies for the cliche title here, in a world, but seriously, things are changing so fast. If you think about it, it's really at warp speed when you think about the utility industry timescale. And so what are these drivers that are causing things to change? Well, for one thing, we're all demanding cleaner, more resilient and distributed power supply at low prices. And so, so this is resulting in really just an explosion of demand-side resources. Customers and third parties are investing in building energy management systems and photovoltaic systems and batteries and backup generators. And all of this is happening, you know, a lot of it is happening without the utility being involved. And the utility, in fact, can't even see these resources on the other side of the meter in real time. And so, you know, part of the problem here is that we have flat and declining demand, and I'll show you a chart of that. I'm not quite sure how to activate the hyperlink here, but this is a trend that has been going on for quite some time. We have aging infrastructure. It's been estimated that something like over $670 billion in new investment is going to be needed just to maintain the system we have by 2020. And when you think about it, it's been said that the utilization of assets on the power system in the US is around 50%. And this compares to something like 75% of assets in other capital-intensive industries. So, you know, huge costs to maintain infrastructure that isn't even used as efficiently as it could be. So combine all of these things with increasingly disparate customer needs and innovation that's considered to be disruptive by the industry. And what it means is that we're running up against a situation where we really, you know, the current regulatory framework and grid design and operations are in need of a massive overhaul. Here's the chart I was referring to, and you can see the decrease in load growth has been quite dramatic over the past few decades. So we're going to need new operational and regulatory models. And you know, a modern grid has to be able to both better integrate distributed resources and you know, by exploiting advanced energy and communications technology. And using fossil resources to do this just doesn't make sense. Kind of defeats the purpose. Utilities are going to need new business models. And if we have a grid that is dynamic and acts as a distributed platform for what we refer to as transactive energy services, then that's going to require an active operator versus today where the operation of the system comparatively is relatively passive. So another problem is that today our regulation is largely backward-looking. We set rates based on kind of what happened looking backwards. And what that causes is utilities become very risk averse, and it stifles innovation and competition. And so we're going to need forward-looking regulation to be able to unlock markets and all of these benefits. So I'm going to talk a little bit about, you know, what is a DSO? What's its structure and role? This is currently being debated, so it's very much new territory. But most people agree that the DSO will be responsible for reliable operation of the distribution system and providing or aggregating somehow demand-side services. It'll interface with the operator of the bulk power system, the ISO or the balancing authority, and as well as owners and operators of distributed resources. Now, there are lots of different visions of how this could happen. It's possible that we could start out with a set of functions that would be relatively modest, and then over time have something that gets a little more complex so that it can ultimately be able to do what we're envisioning here. And so Rahimi and Mokhtari in a recent article have laid out concepts that are along this continuum from less to more comprehensive. And the sort of minimum set of functions they're talking about, in addition to what the distribution utilities are currently responsible for, would include various things that fall within the area of operation scheduling, being able to aggregate and schedule demand-side resources and effectively, create sort of a virtual power plant, as well as schedule them in order to meet the needs of the distribution system. So, and then you have all of the sort of after-the-fact financial settlement. Now, moving to more comprehensive concepts of what the DSO might do, ultimately you end up with possibly the DSO operating a market on the retail side to coordinate and value services that are needed at both the distribution level and the transmission level. And perhaps looking even further out, people are contemplating what's referred to as a transactive energy framework, which is independent energy agents. And by agents, I do not necessarily mean humans. In fact, probably not. In the distribution system, trade and combine services to meet customer needs. So these are some of the kinds of services. As Ben said, these are referred to as ancillary services. And some of these are designed to maintain the reliable operation of the system. And in fact, doing some things that we currently are not really able to do on the distribution side of things, including islanding and various things that would make the system more resilient. So to do all this, we need an entity that's going to do it. And there are some competing visions of what that entity will be. Is it going to be the incumbent utility, as envisioned by the New York Department of Service in their white paper, outlining their vision for a DSO, which they're calling a distributed system platform provider? Or will it be more like the ISO, an independent entity? And James Tong and John Wellinghoff, former FERC chairman, have been advocating. And so there are various arguments to be made on one side or another. It's possible that there's some middle ground in terms of you could have more than one entity, both the utility and an independent entity taking on some of these functions potentially. But this has all to be worked out. I'm not committing to one camp or the other yet, but I'm open to donations. So, so when people, the proponents of the utility as DSO make some arguments, and basically saying that, well, these are the entities that are planned, designed, built, and they run the existing systems, so they're uniquely positioned. They know how real-world distribution systems work, and they engage frequently with the ISO on reliability issues. Also, you have a huge amount of value that's been invested in these institutions and systems, and so by keeping the incumbent utility as DSO, basically you preserve this ratepayer-funded value and you avoid redundant costs. One argument that I haven't heard made yet, but that I'll make myself, is that after sitting through thousands and thousands of hours of ISO committee meetings, it's easy to imagine that people might think twice about setting up yet another institution like this, which will have its own governance issues and cumbersome democratic process. to work through. On the other hand, there are some really good arguments to be made for the DSO as an independent entity. For one thing, on the transmission system, one of the main points of restructuring was to allow open access. Distributed resource owners and aggregators need to be able to provide services to the grid on a non-discriminatory basis. Also, and allowing the incumbent utility to play this role really presents a strong conflict of interest, especially if you're trying to optimize use of assets that may reduce the need for grid expansion or investment. You know, if the utility benefits from expansion and investment, this potential conflict of interest. Also, the current grid operator has clear incentives to favor using the utility's assets over independently owned distributed resources. And then I'm guessing that one of the things that is driving John Wellinghoff's views as a proponent of this sort of model is experience in the US with transmission access post-Order 888, which is illustrative, I think, if you compare areas of the country that have been restructured to areas that have not in terms of open access to the system. So Uday asked me to throw out a few challenges. So in addition to the ones I've laid out already, I thought I would list a couple more here. And I'm just going to go through these without too much discussion. So we want resources to locate and to operate in ways that benefit the system as a whole. You know, how do we do that? Is it simply through spot pricing, or is there something else that will be effective in the sort of planning investment time frame? You know, we have markets for grid services at the transmission and wholesale level, and those are maturing. What are the implications for what we've learned at the distribution and retail level? At the transmission level, we often talk about co-optimizing energy and ancillary service markets, ancillary service commitment and dispatch. So, you know, can we do that at the distribution level? And of the approaches that have been tried, which ones might be best suited? And then finally, how do we design rates that are going to closely align the drivers of costs with how customers are charged? One of the problems up until now has been that customers are charged on a volumetric basis, but that you know, as customers reduce their use and put in their own assets, that reduces revenues that utilities are taking in, and resulting in rates that are higher for the remaining volume that has to be sold, and you end up in what people are referring to as the utility death spiral. So, you know, how do we avoid that? By better aligning drivers of costs with how customers are charged and compensating providers of services fairly. And as I mentioned before, better utilizing the infrastructure that we have. That's all for now, and hopefully you guys will have some other interesting problems and challenges that we can talk about in the discussion.
Thank you, Scott.
Thank you.